How can there be sound if you can't understand it? All you hear is vibrations. We have to rely on these vibrations to collect data. Voyager 1 and Voyager 2 are essential for space exploration, providing real-time data to the far reaches of the solar system. This research is crucial to understanding the universe, but we may not be able to explore this area directly for many years. But NASA engineers were puzzled by the strange data returned by Voyager 1. Why should we be bothered by such strange messages? For nearly 45 years, the Voyager missions have played a vital role in space exploration, providing the first important clues about the nature of our solar system. NASA's twin spacecraft, Voyager 1 and Voyager 2, have become a temporary limitation for future generations. They hold the 8th record for data storage, with 3 million times less memory than the latest smartphone. Data transfer speeds are also very slow, about 38,000 times slower than a 5G internet connection. But they are still at the forefront of space exploration. Our sun and its planets travel through interstellar space, a vast region called the Pacific Ocean. No explorer has ventured into this previously unknown region. Scientists are combining Voyager data with information from previous missions to understand how the solar system and the heliosphere interact with interstellar space. The heliosphere, the sun's magnetic field, may be more spherical than previously thought, contradicting previous comet-like models. The sun releases the solar wind, a stream of charged particles that pushes into the cold plasma of the interstellar medium. This interaction is like a river of pebbles. The boundary between the solar wind and the interstellar plasma is known as the heliopause, and it is a key point in understanding the end of the solar system and the beginning of interstellar space. When Voyager 1 was launched, we had little idea where the heliosphere was. As research progresses, the boundaries of what we know expand. In 1992, after its encounter with Neptune, Voyager began to see powerful radio signals that scientists believe were coming from giant flares. These flares create plasma that reaches the heliosphere, conducting electricity and emitting radio waves. The interstellar medium beyond the heliosphere looks like a vacuum near Earth, but it is much larger than previously thought. By estimating the speed of the outer solar wind and measuring the time it takes to reach this region, researchers were able to estimate the distance to the heliosphere to be between 116 and 177 astronomical units, AU. On August 25, 2012, Voyager 1 passed the heliosphere at a distance of 121 Australian dollars and 60 cents. This transition is marked by several key signs. Particles in the solar wind begin to fall, and the outer solar system's light becomes more intense. But not everyone believed this evidence alone. Voyager 1's plasma instrument malfunctioned, preventing it from collecting particle density data. The team also expected the magnetic field to change after passing through interstellar space, but this did not happen. A series of solar storms in 2012 helped Voyager detect radio waves generated by plasma fluctuations, further evidence that Voyager had entered interstellar space. Voyager 2 passed through the heliosphere without controversy on November 5, 2018. The plasma instrument worked, allowing it to measure particle growth and temperatures between 30,000 and 50,000 K. The solar wind has slowed and the sky's rays have intensified, but the magnetic field has not changed direction. The two Voyagers continue to fly farther and farther from the planet, providing invaluable data on the unknown. However, the research relies on decaying plutonium to generate heat and energy, so energy is lost each year. To conserve energy, NASA has removed systems, including heaters, to protect the continuously operating equipment from the cold. Despite these problems, the devices continue to exceed their useful life. In 2022, Voyager 1 experienced a malfunction in the Attitude Acknowledgement and Communication System, AACS, which provides grounding for the probe's antennas. Despite this malfunction, NASA engineers were able to resolve the problem by switching to additional calculations. As Voyager continues to operate, NASA is exploring options. Travelers must keep their bodies warm to prevent their fat, including their antennae, from freezing. Their lifespan will be limited once their plutonium runs out, but for now, they are continuing to provide data from the far reaches of space through research. The deeper we delve into the mysteries of Betelgeuse, the more divided the scientific community remains. Some scientists believe that the star's rapid decline in recent years will lead to a supernova, while others believe that this is simply a phase in the star's life cycle. The debate has intensified as Betelgeuse's unusual behavior has led astronomers to find new clues. One thing is certain: Betelgeuse will eventually become a supernova, a cosmic event. This explosion can be seen from afar, and its brightness is comparable to that of the brightest objects in the night sky. When it shines, it can be seen briefly during the day, a celestial spectacle unlike any our generation has ever seen. When a supernova occurs, Betelgeuse collapses into itself, releasing a huge amount of energy. When the core explodes, the outer layers of the star are ejected into space at incredible speeds, creating a shock wave that reverberates throughout the universe. The remains of this explosion form a supernova remnant, a beautiful and complex structure of gas and dust that can last for thousands of years, allowing astronomers to detect the death of a massive star. But what does this mean for the country? Despite Betelgeuse's proximity, scientists say the supernova event poses no threat to Earth. At 650 light-years away, the energy from the explosion dissipated before it could reach us in a dangerous way. Instead, we are treated to one of the most incredible scenes we have ever seen. But uncertainty remains. Is Betelgeuse's unusual behavior another beginning? Could this be the first sign of a changing world? These questions remain unanswered, but one thing is certain: Betelgeuse has captivated humans for centuries, and we are still at a crossroads. Now we wait. Astronomers watch Betelgeuse every day, scanning the skies for signs of a supernova that could occur in our lifetimes. The fate of this mysterious star is one of the greatest mysteries in the universe, and once it is solved, it will undoubtedly change our understanding of the universe forever. Until then, Betelgeuse will serve as a reflection of the vast and unpredictable nature of the universe, a tapestry of ever-changing stars, planets, and galaxies, each telling its own story. And when we look up at the night sky, we remember our place in this great dance of life, always watching, always curious and hopeful. One day we will see Betelgeuse's last interstellar journey,